started your warm-up, but I'm going to give you about 2 minutes. Okay, guys, we've learned several types of factoring at this point, but I gave you a hint that you need to start by factoring by grouping. We really always should check to see if there's a common factor first among the terms, but there's not. That's why we're going to start by factoring with grouping. I'm going to rewrite it because remember I taught you when there's a minus sign, I want you to write it as plus a negative because every time you use grouping, I want there to be a plus sign in between the two quantities, okay? So then you ask yourself, what do the terms in the first quantity have in common? And it's x squared that you should have factored out. X plus 1 should be left, right? Because check it, distribute it. X squared times x gives you x to the third. X squared times 1 gives you x squared back again. Remember, what we're doing is the reverse of the distributive property. In the second quantity, remember, because this leading coefficient's negative 25, you've got to factor out a negative 25. So that's going to leave you with x plus 1, right? Because you're doing negative 25 divided by negative 25. Remember, when you're factoring by grouping, if you're doing it right, what's in here should match every time. So your answer is x squared minus 25. And then in parentheses, x plus 1. Now, because we've learned so many different types of factoring, we're actually not done at this point because what's in here can be factored further. Remember, whenever it's a quadratic, like second degree, you might be able to FOIL something out that would give you x squared minus 25 back again. And it's also the difference of squares rule. Like you might recognize that 25 is a perfect square because 5 times 5 is 25. So you're going to write x minus 5 times x plus 5. If you check that and FOIL it out, it is going to give you this back again. And then we need our x plus 1. So this is going to be our final answer, okay? So good job if you made it this far, but we do have to recognize that you can still keep going. So this is going to be our final answer. Okay, so today, guys, we're not really learning anything new until the very last slide. We're going to do one equation solving, but we're just going to basically practice what we did the past 2 days because you have to know when to use each type of factoring. Like in the warm-up, I told you to use factoring by grouping. Normally, it's not going to tell you. Like you're going to have to decide now. So you're going to want to copy this down into your notes. If you want to put it on your formula sheet instead, that's fine. I've always told you if you want to add to your formula sheet, you can. But steps for factoring a polynomial completely. Step 1 is always going to be to check and see if there's a common factor that you can factor out. Then step 2, you got to think of all the different types of factoring you might possibly be using. When we say the old-fashioned method, I just mean what we learned back in chapter 1. Like, what can I FOIL out that would give me the quadratic back again, okay? Difference of squares, we reviewed what that was in the warm-up. Like when we had x squared minus 25, how we wrote it as x minus 5 times x plus 5. We have grouping. We have what we did 2 days ago, sum or difference of 2 cubes. This is already on your formula sheet, so you shouldn't have to rewrite it again. It's just reminding you what we mean when we say sum or difference of 2 cubes. And then quadratic form, we'll review what that means again later on in class today. But basically, this is very similar to this. It's just that it won't actually be a quadratic, but you still have to think about what you do when it is a quadratic. So again, we'll review that later on, but just make sure you're getting this down into your notes. Okay, so factor the polynomial completely. Notice it doesn't tell us how to do it. It just says factor it completely. But the first thing you always need to check is there a common factor among all 3 terms that I could factor out and then write what's left in parentheses? If there is, then you need to see, can I factor this further somehow using one of these methods here, okay? So I'm going to set about a 2-minute timer and let you try it on your own. So the common factor you need to factor out is just an x, so it's going to make it turn to x squared now, minus 7x plus 10. Then again, you're looking here to see, can I factor this further, and if so, how? Well, This is just a normal quadratic equation. Like you might be able to factor it by reverse FOILing. We can wait to put that there until later. So you're just thinking like x times x gives me x squared, right? Jump ahead and think about 10. It could be, well, we know both numbers are going to have to be negative because this is positive 10, but the middle term is negative. So either -1 and -10 or -5 and -2, and that's what will work. Again, guys, if you're still not very confident with reverse FOILing, you're just going to have to sit here and FOIL this out to make sure that it gives you this back again, and it will. So then don't forget about your x that needs to go in front. So this is our final answer for that one. Okay, same thing on the next slide. You need to check for a common factor first. I'm just going to tell you that there is one because I want to remind you that when the leading coefficient is negative, you need to factor out a negative number, okay? So factor out whatever they have in common, and then once you do, think to yourself, can I do something further with what's in here? Okay, give you, again, I'm going to set a 2-minute timer. In fact, the common factor that you want to divide out is -5y to the third. Make sure you take as many y's as you can. -5 divided by -5 makes that +1y squared. 245 divided by -5 is going to make that -49. No more y's because you took all three out front. Now, once again, you have to think, can I factor this further? And again, this is just our normal standard quadratic. Like you're thinking, what can I FOIL out that would give me this back? And it's also a difference of squares. So it should make it really quick to do this one. Like 49 is a perfect square. And we'd have to have y minus 7 times y plus 7. Because again, if you're not sure, guys, you just got to FOIL it out and see. The outer and inner would be -7y plus 7y. It adds up to 0. It cancels. That's why there's no middle term in here. And then don't forget to put this out front. So that's our final answer for that one. Again, looked good as I walked around. Same thing on this one. Check first, is there a common factor? If there is, pull it out and write what's left inside, and then you need to see if you can do something further with what's left inside. One hint. If you're still looking for a common factor, I'm just going to tell you that there's not one. Okay, so you need to think, how can I then factor this using one of my methods in this list here? So go ahead and keep working on it. So again, we're going to be using the difference of two cubes rule on this one. Guys, I want to go back to the last slide for a second. We had a difference of two squares on this one. Like, perfect squares are probably easier for you to recognize because you probably know 7 times 7 or 7 squared is 49. That's probably a multiplication fact that you have memorized. Perfect cubes aren't as easy to just recognize because you probably don't know what 7 to the third is. You probably don't have that memorized. Maybe 7 squared, but probably not 7 to the third. So, like, here's the best way to know. When you see x to the third power, okay, maybe go and check your perfect cube list and see if these things are in the perfect cube list. And they are. Like, there's a number to the third power that would give you this. There's a whole number to the third power that would give you this. Also, like, it just looks like this rule on your paper. So what does the rule say? Again, you basically just follow the directions on your formula sheet. It says a minus b in one quantity times a squared plus ab plus b squared in the second quantity, but we have to figure out what a and b are in order to use this rule. So you have to think to yourself, like, what to the third power would give me this? Because that would tell me what a is. And you have to think to yourself, what to the third power would give me this? Because that will tell you what b is. So again, go to your formula sheet. 125 is the cube of 5. So you can check 5 to the power of 3 in your calculator is 125. Don't forget about the x in there, though. The x is cubed too. So I'm going to write off to the side like a is 5x. Good. So then B, again, you got to think what number cubed would give you 216. Use your list to help you. It's 6. You can check. 6 to the power of 3 gives me 216. So B is 6. So guys, I'm going to kind of write it like this for a second. Well, actually, all right, let's just fill in the first quantity. It's easy because you're just putting A minus B. That's it. The second quantity gets a little bit harder because you have to think about A squared. Well, A, like A is 5x. So you have to be careful that you're squaring the 5 and squaring the x. Like as I walked around, a lot of you wrote 5x squared. You didn't square the 5. It turns into 25x squared plus A times B. Well, A times B, 5x times 6 or 6 times 5x is 30x. And then B squared, B is just 6, so 6 squared would just be positive 36. So this will be our final answer for that one. Again, you basically just follow the rule for a difference of 2 cubes. All right, let's look at this next one. We're going to do the same thing. Check for a common factor first. If there is one, pull it out, write what's left inside, and then figure out how to proceed from there. Okay, I rewrote it for us. Again, if there's 4 terms, it's a big hint to you. Again, there's no common factor, okay? So if there's still 4 terms, it's a big hint that you're going to use factoring by grouping. Remember, you always want a plus sign in the middle. That's why I wrote minus 16 as plus negative 16. In the first quantity, you should have factored out z to the 4th. Remember, take out as many as you can. So if you take out 4 from 5, there's 1 left, and then this would just be minus 3, right? Because you took all the z's out of the second term. Negative 16 is what you need to factor out of the second quantity. Negative 16 divided by negative 16 is going to make that positive 1z. 48 divided by negative 16 is going to make that negative 3. Again, check that these match. If they don't, something went wrong. So, or maybe you can't factor it by grouping. But remember, we're going to write our answers so far as z to the 4th minus 16 in one quantity, and then z minus 3 in the second quantity. Now, this you're not going to be able to do anything further with if it's degree 1. You're always going to be done if it's a degree 1. Degree 4, I'm actually going to rewrite that. That's really sloppy. My exponent was like humongous. Okay, z to the 4th, that also looks like a 2. Sorry, I'm being picky here, but I don't want you guys to get confused by my bad handwriting. So z to the 4th minus 16. Let's think about that off to the side for a second, guys, because that's a quartic polynomial, like it's degree 4. But I want you to pretend like it was degree 2 for a second. Because if it was degree 2, I think you would know what to do with it, like z minus 4 times z plus 4, right? So we learned yesterday toward the end of class that this thing here, even though it's not quadratic, like it's not the same thing as this, but we say that it has the same form as that. Like we say that it has quadratic form. So guess what? The answer to this is going to be very similar to this. It's just going to be things. Z squared minus 4 times z squared plus 4. Okay, let's pause for a minute and FOIL that out to check it. Z squared times z squared is z to the 4th, right? Like if I just put z times z, it would only be z squared. That's why I need z to the 2nd times z to the 2nd. Outer would give me 4z squared, but inner would give me negative 4z squared, right? So that's going to add up to 0, and then negative 4 times 4 is negative 16. So you see what I wrote in purple works. If you FOIL it out, it gives you this back again, okay? Don't lose your z minus 3. Here's the really tricky part. We're actually still not done. What's in here can be factored even further. It's a difference of 2 squares again because it's still a quadratic. Like we can do z minus 2 times z plus 2. If you're not sure, FOIL it out. You'll see that that equals this, okay? And then this part, you could ask yourself, can I FOIL something out? Because it's still a quadratic. But there's nothing you can FOIL out that would give you z squared plus 4. So you're just going to leave it alone. If you're not sure, you just have to play with it for a little bit and see, but you're not going to find anything. And then again, z minus 3, that's already degree 1. There's nothing you can do with that. This is finally the final answer. All right, let's look at another one. This one has a common factor, so I want you to pull that out first. And then once again, what's left in here, start to think about, can I do something further with it? Is there somehow I could factor it? So make sure you have the common factor correct. It's just a c squared. So when you factor that out, you should have 18c squared plus 57 minus 10. And now we're looking at this thing. It's just a standard quadratic, guys. So the type, what's up, Renato? Oh, thank you. Yep, I'm lost to C. Thank you, thank you. You're thinking, what can I FOIL out that you can get back 18c squared plus 57c minus 10? Guys, that's going to be a lot of work. It's easy when it's just c squared because we do c times c, right? But if it's 18c squared, like maybe it's 18c times 1c, or maybe it's 9c times 2c, or 3c times 6c. Like there's so many ways to get 18c squared. So this is one of those problems where you're going to have to do a lot of guessing and checking. Like you're essentially going to make up a FOIL problem, jump ahead and think about 10 now. Like maybe it's negative 10 and positive 1. Or maybe, whoops, negative 10 and positive 1, I meant to say. Or maybe the 1's here and the 10's here. How are you going to know? You just have to FOIL it out and see if it gives you this or not. So I'm going to give you a little bit more time on this one because it's going to take you a little bit to figure out what can I FOIL out that will give me that thing back again. All right, so again, it doesn't matter whether you start with 18 times 1, 9 times 2, 6 times 3. But let's say maybe we try this combination. Again, you just have to FOIL it out and see if it works. 6 times 3, 18, and then c times c is c squared. Outer, 6 times 1 is 6, but inner, negative 10 times 3 is negative 30. 6 minus 30 is negative 24. So already you know that's not going to work because it's supposed to add up to 57. So remember, change what little as you can. Like I would just flip the 10 and the 1. I wouldn't change 6 and 3. I would change one thing at a time. Like put the 1 here and the 10 here now. And that would give me 60C when I do outer and negative 3C when I do inner. And guess what? That's good because 60 minus 3 is 57. Like that's the combination that's going to work. If it didn't, then I would get rid of the 1 and 10 and go on to trying 2 times 5 because that's another way to get 10. Of course, one of them would have to be negative, right? And then don't forget about the c squared that you pulled out in the beginning. So this is going to be your final answer for that one. Okay. This one we're going to kind of do together just because we didn't get to do very many of these yesterday. Step 1 is always the same. Check for a common factor. It's going to be 2x to the third. So let's write what would be left inside if we factor out 2x to the third. This would become x to the fourth minus x squared minus 12. Everybody good on that part? Okay. So what's in here is degree 4, okay? But if you notice, it resembles a quadratic. Like, what if it were x squared minus x minus 12? That, like, just a quadratic instead. Like, all I did was change the exponents. Would you know how to factor that? I want you to think about that for a second. So it'd be x minus 4 times x plus 3. How many of you knew that? Okay, so look, this isn't a quadratic because it's degree 4, but we say that it has the form of a quadratic because you can factor it like the exact same way, except it's going to be x squared minus 4 and x squared plus 3 instead of x minus 4 and x plus 3, because just FOIL it out and check it. If it's x squared times x squared, that will give us the x to the 4th that we want. Outer would give me 3x squared, and inner would give me negative 4x squared, and together that equals negative 1x squared. And then last, negative 4 times 3 is negative 12. So when we say that something's in the form of a quadratic, you're basically like, it's not actually a quadratic, but you're kind of pretending like it is because you factor it the same way. And then just don't forget about the 2x to the third in the front. There is one thing that's trickier about this is what's like in here, for example, is still a quadratic. So you might be able to factor it further. I hope that you're getting quick at recognizing like this is a difference of two squares. Like x, because 4 is a perfect square, right? 2 times 2 is 4. Like I can factor that to x minus 2 times x plus 2. If you don't just know that off the top of your head, you could sit there and FOIL it out and check it, but that's going to give you x squared minus 4. Don't forget this in the front. This is still degree 2. You can try to factor it, but there's nothing you can FOIL out that would give you x squared plus 3. So you'll leave that part alone. So this would be your final answer on that one. Okay, we're going to look at one that's everything we've looked at so far for 3 days has been an expression. Like we haven't had any equations. We're going to look at one equation and you'll see just one, I think one like this on your homework. Don't quote me for sure, but I'm pretty sure there's only one. So first of all, guys, do you remember that when you solve, let's go back to quadratics. Remember when you solve a quadratic, you're looking for where does it cross the x-axis? And remember that wherever it crosses the x-axis, the y is always 0. So this isn't a quadratic, so it just means the shape would be different. So it could look like something like this, for example, if it were to the third power. But you're still looking for where does it cross the x-axis, because another word for solutions is the x-intercepts. So just like back in chapter 1, you always want the equation to say equals 0. So the very first thing that we're going to do is take away the one term that's on this side, on the right side, because 18 minus 18 is 0, okay? On the left side, you're going to want to go ahead and none of those are like terms, like we can't combine x to the fifths with x to the thirds or x's. But when you write it, I would write it in order, like the term with the highest exponent, then the one that's to the third power, and then to the first power. Now, guess what? You're going to take this and try to factor it like we've been practicing all class long. So the first thing you're going to do is check to see if there's a common factor among all those terms. And you would find 3x. So we'll think, what happens if I factor out 3x? Well, this would become x to the 4th now. Negative 18 divided by 3 is negative 6, and it would become x squared. And then 15x divided by 3x is just going to make that 5. Now, that's no different than what we've done so far. There's this equals 0. We'll get to that in a minute, okay? But again, just like every other question we've done, remember how we have to keep checking if what's in here can be factored further. So guys, this is another one that's like what we were just doing on the last slide. It's not a quadratic, but we say that it has the form of a quadratic. Like, let's go off to the side here and pretend that it looked like this instead. I bet you guys know how to factor that. I want you to think to yourself for a second, what could I FOIL out that would give me x squared minus 6x plus 5? And that should be like super quick factoring because 5 is a prime number. So you would just have to have like x minus 1 times x minus 5. So again, this is the same idea, except instead of x minus 1 times x minus 5, it's x squared minus 1 times x squared minus 5. Because FOIL it out and check it, like x squared times x squared would give you x to the fourth. Outer would give you negative 5x squared, and inner would give you negative 1x squared, which together is negative 6x squared. And then last, negative 1 times negative 5 is 5. So that could be factored further. Don't forget the 3x in the front, okay? And then eventually we're going to have to think, how do we make it equal 0? We're not quite there yet, because guess what? What's in here can be factored further. Some of these problems have so many steps because you have to keep going until you can't factor it anymore. This is a difference of two squares. Like, guys, we know 4 is a perfect square, 16, 25. We don't want to forget that 1's a perfect square too, like x minus 1 times x plus 1. If you sit there and FOIL that out, you'll get x squared minus 1. Don't forget the 3x in the front. Can you FOIL out something to give you this? You can think about it for a little bit, but the answer is going to be no. So we have finally factored this as far as it can go. So now we're going to ask ourselves, how do we get this thing to equal 0? Well, when it was a quadratic, there's only two solutions, right? Because a parabola can only cross the x-axis twice. Well, this has 4 factors. Like, look at each of it in pieces. Each factor is going to have a solution. This part's easy. If you plug in 1 there, what's 1 minus 1? 0, right? This part's easy, because if you plug in negative 1 plus 1 is 0, right? This part you might not know. You might have to ask yourself, how can I get this factor to equal 0? Well, if you divide by 3, you're going to get 0. Like 0 is one of the answers. Okay, and then this factor is a little harder because you're going to have to think x squared minus 5. How can I get it to equal 0? I'm going to come over here for a second. Like, you're going to have to actually solve that. You'd have to add 5 to both sides, right? So that would give you like x squared equals 5. And then to get x alone, you'd have to take the square root. Remember, when you take the square root, how you have to say it can be positive or negative of that answer? So like that last answer is not whole, okay? Some of our answers are whole because of those perfect squares in there, like 1 times 1 is 1. There's no number times itself that would give you 5, not a whole number at least. So negative radical 5 and positive radical 5. This has 5 solutions. Like later in the chapter, we'll get into graphing. But what that means, guys, is if you graph it, it's going to cross the x-axis 5 times. It's going to cross it at 0, negative 1, positive 1, and negative radical 5. So that's like negative 2.2. And then positive radical 5, so like 2.2. That'd be a crazy looking graph because it's going to cross the x-axis 5 times.